This problem comes from problem set number 1. It's problem number 33 from 1999. It tells me I have a 1 liter sample of aqueous solution, so 1.0 liters, and it tells me I have in that 0.1 mole of NaCl and 0.1 mole of CaCl2. I'm noticing right away that they both have Cl, so I'm wondering if that has something to do with it. It says, what is the minimum number of moles of AgNO3 that must be added to the solution in order to precipitate all of the Cl minus as AgCl solid? Okay, again, here's the word precipitate. So I know that I'm taking Cl minus, I'm adding AgNO3 to it, and I'm making AgCl solid, and I'm guessing then I'll also have nitrate there. The nitrate is always an ion, it's always soluble, so I could actually just totally ignore it, and the point is I'm taking my Cl minus, adding it to Ag plus, and that's what's making this AgCl solid. So what they're telling me is I need to make sure all this Cl is reacted to make the silver chloride. It wants to know the number of moles that must be added. So if I look here, let's start first with the NaCl. I have 0.10 moles of NaCl. And I'm going to do a little T-chart because really what matters is how many moles of Cl there are. Well, in 1 mole of NaCl, I have 1 mole of Cl minus. So that means I have 0.10 moles of NaCl, of Cl minus, sorry. Now, if I do the same thing, just looking at the CaCl2, I can tell you there's twice as many Cls. If I give you 1 CaCl2, you have 2 Cls. So if I give you 0.1 moles of CaCl2, and I actually do out my T-chart for that, in 1 mole of CaCl2, I have 2 moles of Cl minus. So that means I have 0.2 moles of Cl minus. Altogether then, I have 0.3 moles of Cl minus. So if I have 0.3 moles of Cl minus, and I need to totally and completely react that in my balanced equation, 1 mole of Cl minus reacts with 1 mole of AgNO3. So that means I need 0.3 moles of AgNO3, which is my final